The change of base property of logarithms teaches us that if we would like to come up with the exact value of this expression, where the base is not easily provided by any calculator, we can actually break it into this quotient form where we can plug in here the easiest base of 10. So it tells us that if we have the logarithm of x to the base a, we can just simply take in a rational expression where we have here the logarithm of x, this expression, to a base b over the logarithm of the base a here to the same base b. Again, this is usually done if we are trying to come up with the exact value of this certain logarithm with using calculators that do not provide us with any other base aside from 10. So say for example, if this is logarithm of 7 to the base 2, and your calculator is not a calculator that will help you solve the value of the logarithm by changing the base into 2, only 10. So we can have this change of base property. And we're going to show that this is true for this video. So let us have this proof for the change of base property. What we need to do here is to give another expression, representation for this entire form here. So we're going to have let logarithm of x to the base a, let's say it's equal to k. And once we have that, we are going to manipulate this in such a way that from this same left-hand side, we reach to this form using the entry that we have here as k. Now, take note that if we have this, we have the transformation of logarithmic equation into exponential equation in this manner. Logarithm of a to the base b is equal to, let's say, y. We can transform this into an exponential equation with this base b, y is our exponent, and a, the coefficient of your logarithm, is its equivalence. So this works both ways, from the left-hand side to the right-hand side, from exponential to logarithmic, and vice versa. We would like to do this because from here, so with this, we can now come up with an expression of k. Okay, one expression of k here, which is x rather, expression of x. So we'll have here, we have, using this transformation, you have a to the power of k is equal to x. Again, base, this will be exponent, and this is equal to the coefficient here. We are doing this because we would like to have this form in our expression here. A to the power of k is equal to x. This is the part of the proof. We are going to introduce the logarithm of both of the sides into a base, certain base. Let's use base b in this case. So bear with me with this. So if we are going to have the logarithm, since they are equivalent, okay, since they are equivalent based on this transformation, therefore the logarithm of a to the base k, to power of k, the base b, is just equal to the logarithm of x to the base b. Take note that we have this and that already established as equality. So if we have the logarithm of that a to the power of k to the base b, and the same expression is here, definitely this is also equal to each other. Okay, this is also equal because the expressions here are also already equal based on our earlier analysis. So from here, I would like you to apply the power property of logarithms, as we have here an exponentiation. So with the power property, we can bring out the exponent as the coefficient or multiplier of the logarithm of a to the base b. These two are just equal to one another according to the power property, and you might want to review that specific video proving that or showing that reality. So again, if you have this, take bring down, that's the term we've been using, or you can simply make this exponent as your coefficient of the logarithm of simply the base over base b. This is still equal to the logarithm of x to the base b. Okay, now we would like to divide both sides by logarithm of a. So let me have it like this. Okay, I'm going to add here another step, times logarithm of a to the base b. I'm going to divide this side by logarithm of a to the base b. So this could be cancelled out, leaving x. Why do we want x here? Because that's the original left-hand side of the property, the logarithm of x to the base a. Okay? But of course, you do the same thing on the other side to retain equality. The logarithm of a to the base b. Okay? We just divided both sides with the same quantity. So with this, we have here an expression of k equal to this form. The logarithm of x to the base b over the logarithm of a to the base b. Okay? And what is k? As mentioned, k is this one here. So we can now further say that k, let me capture this with the screen, this one here. Okay? So the logarithm of x to the base a as our k is just equal to the quotient of the logarithm of x to the base b and the logarithm of a to the base b. This is the property or the change of base property, which tells us again that if we have something like this and the base is not possible for any calculator, you can make it as a quotient of the logarithm of the coefficient here to a certain base b, and to be divided by the logarithm of the base a to the same base b. Again, take note, this should work. The bases here should be the same. That is the emphasis here. They should be the same, of the same base. This is now the proof of the change of base property as shown here. So this is properties, laws, and theorems. Please subscribe now.